All right, so in this notes, we're starting a new section, chapter 8-7 in the textbook. Still factoring. You can kind of see the theme here is still factoring. This is going to be one of the longer types of factoring. After this, it should get easier. So this is one of the most difficult types. But it really combines what we have been doing. If you can print this, print it and do it along with the video. If you can't, just do it on paper. You don't have to copy everything, just do the example. So, this method of factoring combines two previous methods that we have covered. This method is important to know when the leading coefficient of a quadratic expression is not 1. So, I call this the A times C method. And it uses grouping, which is what we covered last week. So hopefully you did well on that. Let me show you some examples. All right, here's two examples of quadratic expressions that we would use this method with. The important quality about these two is the number in front is 2 or 3 and not 1. So this method uses grouping, and we use this method when A does not equal 1. So when there's a number here, it's not the invisible 1, you use the method on this paper. Factoring ax squared plus bx plus c. So there's a great example here in your textbook. It's page 510. This section is here. I really encourage you to read your book. These examples come out of the textbook, so you might see some great stuff in there that helps you understand this. I'm gonna get right into the first example. Hopefully this is bright enough. Okay. So the directions say factor each quadratic trinomial where a is greater than 1. So here we have, the reason it's called A, I really want to use pen so you can see it. I want to highlight why it's called A. So A is always referring to the first number. So in this expression, A is 7. B is 29, and C is 4. So, step 1 in factoring is find, multiply A times C. So the first number and the last number. So 7 times 4 is 28, and feel free to use a calculator while you're learning this, it's okay. Step 2, find two numbers that have a product of A times C and a sum of B. So, we need numbers that will multiply to 28 and add to 29. So, what multiplies to 28? 1 times 28 and 4 times 7. 1 plus 28 is 29, so these are our numbers, 1 and 28. Now that we found our numbers, we can't just jump straight to parentheses. There's some extra work. And the reason that there's some extra work here is, again, because there's a number in front, because of that 7 in front. So our next step is to put the numbers that we picked in the original expression. So here's our original expression. We're going to put our numbers right in the middle. So I'm going to keep the first number the same, the first term 7x squared. Instead of 29, I'm going to use the numbers I picked here, 1x and 28x. And then I'm going to keep the last number the same. So When you see how I've changed the problem, this is the original. I kept the first term the same. I rewrote the middle and I kept the last the same. The reason the middle is rewritten, well, let me just highlight the fact that 1 and 28 make 29. So I haven't actually changed the problem. I've just rewritten it. And the reason I've rewritten it is so that I could factor by grouping. In order to group, we need 1, 2, 3, 4 terms. So now that the expression has 4 terms, factor by grouping, which is what we practiced last week. So if you didn't quite get it last week, we're practicing it more right now. I'll rewrite it for you. So when we factored by grouping, we grouped the first 2 together and the second 2 together. Plus 4. And then we took a GCF out of both. So when I look at these first 2, the only thing they have in common is x. When I look at the second 2, they both divide by 4. And 4 divided by 4 is 1, leaving a 1 there. Now, remember from notes last week that the parentheses have to be the same. And since they are the same, we'll write them together, and then we put the numbers out front in one set of parentheses. So this is our final answer. 7x plus 1, x plus 4 is the correct factored form of example number 1. And you can check that out in your book. All right, next page. Feel free to message me with any questions. You're also going to be seeing this in Khan Academy and Alex, so really try to figure it out. Read your book, message me, all that. All right, so our next problem has a 5 in the front, a 13 in the middle, and a 6 as the constant. So I'm going to go ahead and label those. A is 5, B is 13, and C is 6. Multiply A times C. 5 times 6 is 30. Find 2 numbers that have a product of 30 and a sum of 13. So what numbers multiply to be 30? 5 times 6, 1 times 30, 3 times 10. Okay, what are the sum of these numbers? Well, 5 plus 6 makes 11. 1 and 30 makes 31. And 3 and 10 make 13. So we were looking for the sum of 13. So 3 and 10 are our numbers. So we're going to put those numbers in the middle of the original expression. The original expression has 5x squared first. I'm not going to write 13. I'm going to use the numbers I picked. And it doesn't matter what you put first. It'll work out either way if you picked the right numbers. Okay, so I kept the 6 the same. That's super important. People make a mistake there a lot. Kept the 5 the same. Instead of 13, I have 3x and 10x, which really is 13, just written differently. Now that we have this 4-term problem, there's 1, 2, 3, 4 terms, we can factor by grouping just like we covered last week. So I'm going to group the first 2 together. I'm going to group the second 2 together. And then take out a GCF. Looking at my first 2, 5 and 3 don't have any number in common that they both divide into, but they both have x, so I'm going to put an x out front, leaving 5x plus 3 inside. I took 1 out, and that's what I have left. 10x and 6 both divide by 2, so I'm going to put a 2 out front. 10 divided by 2 is 5. 6 divided by 2 is 3. And good news, the parentheses are the same. That has to happen. If that does not happen, you have made a mistake. Since they are the same, we'll write them really as a common factor. We keep it once, and then we put the x and the 2 together. And the x and the 2 are these numbers out front for our final answer. That's the factored form of the problem. Remember, you can always check. If you multiply this out, you get exactly what you started with. Number 3. No steps. Follow the same step as before. Okay, right off the bat, I know this is going to be more difficult because of the subtraction sign. This light is super distracting. It's probably distracting. All right, negative 12. So what multiplies to be negative 12 and adds to be 11? We have negative 1 times 12, negative 3 times 4, negative 2 times 6. Negative 1 plus 12 is 11. So these are the numbers we want to use. You take those numbers and you put it in the middle of this problem. I'm going to switch the order this time just to see, just so you know you can put it in any order. So I'm going to put the plus 12 first, the minus 1x next, and the minus 4. Now I'm going to group them. And I'm only using pen here so that you can see it easier. I hope you use pencil so you can erase when you mess up. Now I'm going to take a GCF out of each group. Both of these terms divide by 3 and they both have x, so I'm going to put a 3x out front. 12 divided by 3 is 4. Had an x, I took an x out. This is interesting. They're both negative. 1 and 4 don't divide by anything other than 1. So the GCF here, I'm going to put a negative 1 on the outside. Always, when both of these are negative, take a negative out. So that's going to leave me with a positive x and a positive 4 inside. Taking a negative out leaves you with positive left over. All right, just like last week, these are the same. So to finish up, we're going to have one set of x plus 4 and then the 3x minus 1 as your second factor. They come together. All right, next two. All right, picking up where I left off, number 4. I'm gonna make a list. Of A, B, and C. We'll do A times C. Need to find numbers numbers that multiply to 60 and add to negative 17. So, cannot see. So what kind of numbers would multiply to 60? We got negative 6 times negative 10, and that adds to negative 16. We got negative 60 times negative 1, that would be negative 61. We got, negative 30 times negative 2, that would be negative 32. And I feel kind of stuck here. So one method when you're stuck is to start looking at factors of these numbers. So I can't remember anything else, so I'm going to go to my calculator and I'm going to think, well, what does 30 divide by? And 30 divides by 6, and 30 also divides by 5. So since 30 divides by 5, 60 must also divide by 5. So what's 60 divided by 5? Oh, it's 12. So negative 5 times negative 12 is 60, and negative 5 minus 12 is negative 17. So our numbers are negative 5 and negative 12, and that takes a lot of practice and time. The more you practice factoring, the easier these tricky numbers come out to be. So just stay with it, keep practicing. I'm going to take my original problem and I'm going to write negative 5 and negative 12 in the middle. And then I'm going to group. And then I'm going to take out a GCF. The only common factor here is x. Taking an x away from both. Here, these both what? They divide by 2. They also divide by 4. I'm going to take a negative 4 out. Negative 12 divided by negative 4 is a positive 3. 20 divided by negative 4, negative 5. Has to be the same. They are, so I'm going to write them first. I'm going to bring the x and the 4 together. And that is the answer. So that was a challenge problem. I'm glad it was included here in these examples. It is in your book as well. It is challenging to find numbers that multiply to 60 and add to negative 17, and then factoring this negative out and changing signs. That's pretty tricky. Last problem for the notes. All right, B here is negative 1. There's an invisible 1 here. C is also negative 1. What's gonna multiply to negative 2, add to negative 1? What multiplies to negative 2? Negative 2 times 1. Negative 2 plus 1 is negative 1. So our numbers are negative 2 and 1. We'll put them in the middle. We'll group. Take a 2n out. Here, there is no GCF other than 1, so I'm going to put a 1 out front. You must put the 1 out front. Same. That's the factored form. Okay, like I said, watch the videos in Khan Academy. Look at the examples. They're going to go through all of this with you again. And there's more examples to help you on ALEKS. So just doing this in Khan Academy and ALEKS, possibly an assignment on Schoology. Message me with any questions. Thanks.